Hello, everybody, and thank you, Andy, for that introduction. I wanted to mention also that there should be a link in the chat for notes for this session. You're welcome to put some notes in there and also questions. I'm Phil Durbin. As Andy mentioned, I'm a community manager for OpenDP. And since we heard so much about Dataverse in the previous session, I have to mention that I'm also a developer for Dataverse. The agenda for today is for me to talk about 15 minutes about contributing in general to the OpenDP project. As Andy said, we welcome contribution. And then for 15 minutes, Mike is going to narrow in on contributing to the OpenDP library itself. And then we'll have plenty of time for questions at the end. So contribute in general, or you might be asking yourself, how can I get involved in OpenDP? Well, the first way is just attending this event. So thank you for coming, first of all, and especially thank you if you are speaking or moderating or have volunteered to take notes during this meeting. These are excellent ways to get involved, to contribute, and we really are very grateful for that. Thanks also to those who have spread the word about this event. And at the end, we will be asking for your feedback. So please do give us feedback about this event so we can improve in the future. Now, the thing I'd like to highlight the most is the best way, perhaps, to contribute is to actually use the software. We're super excited to have our first public release, 0.3.0. It's out there on GitHub. It's on PyPI. It's on Rust crates. Now, finally, you can try out the software, and we are ready for your feedback. The way that we have oriented the documentation is we're assuming people are going to want to use Python to use the library. So I'm going to emphasize the use of Python here when I explain how to get started using the software. And this is really oriented toward how much we want feedback from you, not just on the documentation, but on the APIs themselves of using OpenDP. So please keep that in mind. Okay, so first we're going to dive into Python in the docs. So our new website for documentation is docs.opendp.org. And at the top, you'll find a link that says examples. You'll be taken to this page here. In there's a section called Python docs, and we see 5 bullets here. Each one of these is a deep dive into different ways to use the OpenDP library. So DP, sum, and chaining, for example. Mike Shoemate, who you'll hear from soon, wrote up all these excellent docs. So I highly encourage you to jump in and start checking out these examples. Also on this examples page, you'll find a section on Python notebooks. So these are Jupyter notebooks. And the part that I want to highlight the most is that there is a link in here to a tool called Binder. And I put the logo here at the top. Binder is a service at mybinder.org where you can put in a Git repo or even a Dataverse DOI and start playing around with code and data in your browser. So there's no need to install anything. So to me, this is the easiest way to get going with OpenDP. Go to the docs website, click on examples, click on Binder, and I'm going to step you through what that looks like. This is Jupyter Lab, which is what you'll get to once you click that Binder link from the OpenDP docs. And on the left, you can see that the entire Git repository of OpenDP has been cloned into well, it's a Docker VM. And then all the folders are here: docs, Python, Rust, the README. You're going to click on the Python folder and then click on the example folder. That's where we keep our Jupyter notebooks. And Mike showed this notebook yesterday. It's a good one to start with, this basic POMs analysis with OpenDP. If you're not familiar with how Jupyter notebooks work, basically you can just click the run button for each one of these cells and you can execute that code. But not only that, you can also edit the code. So this is a great way to really get your hands dirty, reading all the inline text and changing things as you see fit to get a feel for how the software works. Also on that examples page in the docs, we have an area for applications. We just heard all about DP Creator. It's obviously listed as a sample application, but this is an excellent way for you to contribute, where you've been playing around with OpenDP and you're proud of your work, you could make a pull request against this examples page and list your application. We'd be happy to highlight examples of using the OpenDP library from all of you. And then I have a line here about someday part of the OpenDP Commons. We heard about the OpenDP Commons already from Salil and Andy and others yesterday. We basically, we're considering any tool that has been built upon the OpenDP library and has gone through a vetting process to be part of the OpenDP Commons. But my thought here is that perhaps we could have a much lower bar for what we consider to be an example application, and we can collect a nice pool of software there. And from that pool, we can decide, okay, we need to put some of these through the vetting process and have them eventually added into the OpenDP Commons. This process of vetting is not completely ironed out yet. Right now, we have the library itself as part of the Commons, and also DP Creator. But we hope to have this just grow and grow over time. We've been stepping through the documentation a little bit. One thing I wanted to mention is that the documentation is actually in the OpenDP Git repo. So when you edit the documentation, you're actually contributing to the OpenDP library itself. So even if it's just a typo that you fix, it counts as a contribution. So thank you in advance for that. The documentation covers more than just the library. We've already talked a little bit about Jupyter notebooks and example code, example applications. This text that I've put up here, that's kind of askew, are all from our resources page. So we're trying to educate people about differential privacy, and I welcome people to take a look at that resources page and help contribute additional resources that you think would be good. There's a frequently asked questions section. We've covered the OpenDP Commons, and then I'll just mention that we also link to related projects. OpenDP is not the only differential privacy software in town, and we're happy to promote DP in general and suggest other projects you might also want to check out. I want to emphasize again that feedback is a gift, so please do give feedback on everything from the software itself to documentation. For bugs, we're using the standard GitHub issue tracker, so you can just go to OpenDP on GitHub and open an issue there. For features, we're trying out a new feature, relatively new feature of GitHub called GitHub Discussions. So our thought was you can start a new discussion there about a feature you'd like to see in OpenDP. And then there's actually a button that we can click just to convert that discussion into an issue. And speaking of discussions, we have both GitHub Discussions and the Google group, which has been around for a while. Both are completely valid ways to talk amongst yourselves and us about OpenDP and DP in general. So we're very happy to see the free exchange of ideas among all of us. You know, we don't want to just be sending announcements. We want you all to talk amongst yourselves as well. So please ask questions, answer questions, share ideas. We just want to encourage discussion amongst everybody. Okay, and then this is just sort of a brain dump from me of other thoughts, things I've seen in Dataverse or other open source projects. When you're ready to do code review, I'm sure we'll be happy to tap you for that service. Probably most code review is going to be done by Mike and Andy for now, I would say, for the OpenDP library. But of course, there are other apps like DP Creator. Other people are doing code review there. We can always use more tests. So if you like writing tests, that's a great way to contribute. Translations, I'm not sure if we're quite ready for that yet, but I put this here just to remind us that you know, documentation can be translated into other languages. Perhaps DP Creator, since it's a graphical app, could be translated into other languages. We haven't done a ton of user research, but that's a great way to contribute to projects is participate in user research. Thankfully, we don't have hundreds and hundreds of open issues with OpenDP yet, but issue triage is a thing where just identifying duplicate issues and stuff like that is a huge help. We've talked internally about some sort of a playground or contrib area. I would say we'll hear about this in a bit about like proofs for OpenDP. how you may not have to contribute everything at once. So just keep that in the back of your mind, that it doesn't have to be a complete perfect contribution. It's okay to contribute some pseudocode or an idea, that kind of thing. If you're artsy, maybe you want to make us a mascot. We do have a logo, more on that in a second, but we could always use more. And then these are just some ideas for me. Again, a discussion in the public on GitHub Discussions is great to talk about other ideas or with a Google group, or you're very welcome to email info@opendp.org. So for the logo, I gave it to my daughter in early July. It was around fireworks time, and so she put this together for us. So you can never be too young to contribute to OpenDP. And now we're going to move into Mike talking about contributing specifically to the OpenDP library. But before I hand it off to him, I'm going to step you through some of the process. I apologize for how dense the slide is, but I wanted it to be accurate. And then I'm going to jump to this lighter version in a moment, so don't worry. So we've outlined a contribution process. It's still being thought about, still being kicked around, but I'm going to try to go through this somewhat quickly. The idea is that the contributor is going to make a pull request. There are going to be three things in there: code, pseudocode, and a proof. Okay. And now what happens to all that stuff? On the other side, we have committers and an editorial board. Okay. The committers are basically like Andy and Mike, I would say, for the most part. They're the ones who are like really writing the code for this library. And they're going to look at the pseudocode, which is really for the editorial board, because they're not as deep into Rust as Andy and Mike are. Look at the pseudocode and confirm that it's a faithful rendition of the actual code. So yep, it matches, the pseudocode matches the actual code well. And then at that point, the editorial board, who's folks like Salil, who really know the proof side of things, are going to look at the pseudocode and the proofs and make sure that they're mathematically sound and that they demonstrate the intended privacy properties of the algorithm. And then this is just sort of the number 4 step is the committers looking again at the code, just making sure it meets style guidelines. And then this 5th step is just sort of recognizing that this is going to be a loop. It's going to be a process of back and forth with the contributor until until all critical issues are resolved. And then the final step is to merge the code. So that was a lot. Someone asked, can we have a diagram? So I came up with this. I hope this sort of makes sense, but basically, and I added an extra step of like just creating the issue in the first place, the proposal, talking about, hey, I want to do this thing. And then the 3 parts of the pull request: code, pseudocode, and proof. The board saying, yeah, the proof and the pseudocode look good. And then the committer saying the code indeed matches the pseudocode and meets our guidelines. It's okay to merge. So I hope that helps tee up Mike to dive deeper into the library contribution process. I'm going to go ahead and stop sharing my screen and hand it over to him. Thanks.
All right, great. So I'm on the docs website. I'm going to focus on the developer guide down here. This getting involved section at the start goes over a lot of what Phil has already talked about. So I won't go into too much detail, but if you already know what you want to do, then please just open an issue with a summary of what you're looking to do, and we'll get back to you with some ideas on integration with the library and next steps. That's that feedback part of the previous slide. And if you're not sure what you want to do yet, then we have this massive issue board with it's not, I guess it's not massive yet, but it's got about 90 issues now, with some marked as good first issues. So that's a good place to get started if you're not sure what to do right off the bat. But there's lots of different ways you can contribute. This is just like drilling down into the code and the proofs. Once you know what a direction you want to go in, we can enter the contribution process. I'm going to skip through the development setup because it's probably going to differ for everybody's own setup. But there's typically 3 different pieces involved. I'm thinking of the actual constructor, or the code that implements your algorithm, as well as the proof and pseudocode. And then there's also this FFI layer, and I'll talk about each of those in more detail. So building the constructor function, I think the best way to show this is just to go down to the code. This is my local clone of the OpenDP repository. You'll notice the folders on the left side here are very small, but they're also the same as in the OpenDP GitHub. So under Rust, under OpenDP, so we have 2 crates here with an OpenDP crate and an FFI crate. I'm going to go into the OpenDP one. That's where your constructors are going to be for the most part. Under transformation, inside the sum, I'm kind of extending the previous demo from yesterday, but showing the flip side of the coin, the internals of the sum. We have a constructor, and there's a lot of code to look at here, but I'll break it down into smaller pieces. This first block is the signature. You call this function with a size and a bounds. Size is the number of records in your data set. Bounds is lower and upper bounds on the elements in your input vector. And it returns a transformation. So this fallible type is representing something that could fail at runtime. And if it doesn't fail at runtime, if it's successful, it returns a transformation. And the rest of this lengthy type signature is filling in the generics on the transformation. We need to know what the input domain is, the output domain is, the input metric, and the output metric. So input domain, output domain, input metric, and output metric. And this input domain is kind of lengthy, but even that's not too scary. It's saying that the input is some kind of vector with a known size consisting of bounded data of type T. You'll see this a lot throughout the library. We don't specify types up front, but we do provide something called a where clause that provides restrictions on valid types that can be used. So this has to be a type that implements some concept of subtraction and summation and casting, etc. We make use of these traits in the implementation down below. The next section of this code block, I'll break it here. Next section of this constructor is doing some runtime checks. Before you are able to build your you're able to build your transformation, we run all the checks possible to make it so that the function, when it is invoked, is infallible. We want the function to not have the possibility of failing, because that brings along a lot of privacy indications on, well, if it failed, then what does that tell us about the underlying data? So we'll pull all those potential failure routes out into checks at construction time, and these are safe to pass back out, as they won't, at this point in the process, you do not have access to the data yet. So the next part of this is building a transformation. Transformation, if I follow this down into its definition, consists of 6 different pieces: input domain and output domain, a function that you can use to actually make your transformation or release as well as an instance of an input metric and an instance of an output metric, and another function that encapsulates the privacy characteristics of this transformation. So it's the same thing we talked about yesterday, but a little bit more detailed now. So I'm making instances of these things. This is describing a domain based on the input arguments, and describing an output domain. We know that after we sum, it could be any number of type T. So this is not very prescriptive about the output type. It's just that it's a scalar, a non-null scalar. And we don't even specify the type here because the compiler is able to infer it from the context. So it knows that this has to be an all domain of T, and allows you to omit some of these details. If it's ambiguous, then the compiler will definitely let you know. And then a stability relation. So we've got some, this is making use of a useful constructor for a stability relation that only takes in a stability constant. And this is a bit of a simplification. All it's using is one constant that is a little bit loose. I just switched it to make this demo a little bit easier to grok. And of course, as you're developing your constructor, make use of tests. This is very useful for debugging and identifying issues and just checking to see if things are as you expect. All right, so I think that sums up the code. All right, I'm sure there's plenty of information here that didn't fully stick, so we'll be happy to provide more feedback and support for how to get started. And we're developing the docs further. Okay, so also the proof section typically consists of 3 different requirements for the proof itself. You want to show that the function, when evaluated on any element in the input domain, and it's a value in the output domain. So back on that example I was just running, we know that the output of our function is always going to be in all domain of T. So we need some proof that justifies this statement. Similarly, capturing the privacy characteristics of the stability characteristics in the case of our bounded sum, and another proof that justifies your choice of stability constant or relation. And we want to make sure that the metrics that you've chosen are compatible with the domains you've chosen. So it's not valid to pair a symmetric distance metric with an all domain, because members of an all domain aren't comparable with a symmetric distance metric. So these pieces are important for showing that your proof is valid. So I've got an example pull request here. It's a pull request from Sylvia, and it looks like Connor and Grace have also done some work on it. And it's containing the proof, and it's, if you look down in the comments, it's got a lot of feedback from reviewers and from Salil. As always, it's an iterative process. We're going to find places where there's doubts or things aren't clear to us or haven't been fully explained. So those will pop up in the review comments. And then looking at the proof itself, this is the attached PDF. We just compile the LaTeX and get this. If you look down in the code, it hits on those 3 pieces I was talking about before: appropriate output domain, domain metric compatibility, stability guarantee. Each of those is in its own little subproof. I shouldn't say little, it's a significant amount of work. Also, alongside the proof comes the pseudocode. And we've got a little snip here that has a more understandable explanation of what needs to be happening in the actual Rust code itself. Going down the line, when the review, when the proof is merged and vetted, we also make sure that the pseudocode that you provide here is isomorphic with the Rust code in the repository. We're linking all these pieces together to make a full chain from proof statement to implementation. All right, so really thankful for having Sylvia, Connor, Grace doing their work on this. This is great work. I'm gonna hop back out to the FFI wrapper. This is the third piece of contribution process, and we don't expect you to become an expert in C, and we don't expect you to learn the inner workings of our language translation process, especially right now, since that layer is still being developed. This is something that a core developer like me pitches in on. And ultimately, we want your algorithms to be broadly accessible in many languages and platforms. So we've done a lot of work to. We're excited to see this process continue. And then once your work is vetted and once your work is vetted and the review process is complete, you're into the main branch, and you'll see your contribution available in the next release of the library. So it'll be available on crates.io. So going forward, I intend to be doing some Twitch streaming and just like open myself up to people who want some additional guidance on direction and coding and etc. for this process. So your eyes open for that. I like to explain my coding process as I go along, and I think it's helpful for people just getting started. All right, with that, I'm gonna pass it back to Phil. Thanks for your time.
Thanks, Mike. I think what I'm going to do is just share the doc of questions that have come in. We're sort of just still cleaning it up here, but let's see. The first one came from Christine, and I'll just read it out here. Will there be any required check or demonstration of the utility of the algorithms in addition to their code quality and privacy properties? Is there any interest in including utility metrics and/or benchmark problems in the library? So, Mike, I'm going to pass that one to you, unless someone else jump in.
There's definitely include things in the library that don't have reasonable utility. I'm just going to link you to a section on the Getting Started guide that talks a little bit more about this. It's there in the chat. Basically, when you open an issue with a potential contribution, we would like some additional comments on how it adds something new to the library, if it has reasonable utility, and what research you've done towards that end. If it has a similar behavior as another constructor, can you show what trade-offs it has that are better, or if it has greater utility in general? So yeah, we don't just accept anything, but we're very open to contributions regardless.
just another point about that. Utility, it's a challenge, and you know, something we're still grappling with in the context of differential privacy. And so if folks are interested in that in particular, there's a breakout session tomorrow about statistics, confidence intervals, utility measures, black box estimators. So that would be a good place to learn people's ideas about utility.
Great, and I'll just read the next one from Hal. Would the same process be followed for additions to the core library focused on external/distributed computing, or would that qualify as an external app?
Yeah, so we want the function invocation itself to implement the same thing as the pseudocode and the proof. This will be a case-by-case process, and we don't necessarily have the same constructors for. There may be cases where so yes, but it'll be a case-by-case process. Reasonable or human, we're going to work with you.
Yeah, I'd also say that's another thing we're still kind of figuring out, but at the very least, you know, we need to have some way of demonstrating that any external module lives up to the same expectations of any sort of in-process computation. So even though it may sort of live somewhere else, it's still got to undergo the same sort of vetting process, I believe.
Sorry, I'm typing. The last question so far is pretty straightforward. Will these videos be available on the docs site? And I guess I would say, I think the answer is that maybe the docs site, but definitely the main OpenDP website, which is opendp.org. That you should be able to find, I can just bring it up since I'm sharing my screen, videos from last year. Under events, past events, oh no. They're here somewhere. Here we go. Yes, so we have all these videos from last year, and I'm sure it'll be similar for this event.
I also want to append to that previous question. There are different levels of vetting. For the code to be in the core library without the contrib flag, you've got to have this proof and pseudocode and vetting process, etc. But there's a lower level of inclusion via contrib that still needs to meet some reasonable checks, but isn't as involved of a process. We do expect to contrib to eventually have proofs, but it's there's different tiers of inclusion here.
Yeah, and Mike, it just makes me think that you actually demoed that yesterday, I thought, with your live coding, where you put a line in saying like it's okay to use contrib, right? So
long as you understand the consequences.
Yeah, right. But what I'm trying to say is that like we're still in the process of moving our own code out of contrib by writing proofs for that code. Do I have that right? So
yeah, the whole library is currently in contrib.
Right.
The vetting process is underway.
Right. We're eating our own dog food, you could say.
Dog fooding.
Dog fooding.
Kind of.
A couple more questions have come in chat. Kevin asks, is there a list of stats available?
In the chat, there's a section in the available aggregators.
Yeah,
So count distinct, count by categories, count by, which is like a stability histogram, a bounded sum, an alternate version of the bounded sum, a mean, and there's a covariance in Rust. We're still working out the internals of those that, and there's lots of other stuff that in various levels of development, especially mechanisms and compositors.
Yeah, so there, if you go into the user guide in docs.opentb.org, there's a section on, I think it's titled Transformation Constructors, that would list, give you an overview of all the summary statistics, and then you know, there's further details in the API doc section. Okay, and then Christine mentioned she likes the idea of letting new contributors explain what their solutions add to the existing work. Sounds like a great idea. I wonder if shared realistically complex benchmark problems might make it easier to compare different algorithms of the same functionality.
That would, I opened an issue related to that last night. I think that's at least a good first issue to start setting up some benchmark problems for common statistics.
Yeah, I think that's great. I mean, on the one hand, we don't like we want to be open and you know, have an environment for people to explore new ideas, but you know, so if something doesn't immediately have the state-of-the-art utility, that doesn't mean that people shouldn't think about it for OpenDP. But that said, it's great to know how things compare, and so I think having benchmarks would be a nice way to do that.
Well, we have, I think, 3 minutes left. For some of us, it's lunchtime, but there's no rush. We can hang out.
I just want to quickly add regarding the videos. Yesterday's videos from the plenary talks are already posted online. If you visit our agenda page, links to those videos and slides are already there. So after today's session, we're going to do the same, post Phil's shown it, you know, post these videos in the notes, right, and slides, so you can access them right away. After this community meeting, we might move this agenda section as a summarization page onto our main website, so they will always be available.
Great, thanks, Annie.
No problem.
Yeah, the issue I opened was for execution time benchmarks, not utility. That would be a separate issue. So there's not one there yet, but there should be soon.
Coming soon.
Either I'll add it or someone else will.
If there are no more questions, can I chime in?
Yes, please go ahead.
All right, great. Yeah, I just wanted to follow up on the discussion that was prompted by Christine's questions. So Andy already made a plug for the statistics breakout session, and just to elaborate a little bit more on that, one of the things that I think we would love to see coming out of those discussions is a community working group that's thinking about what should be our process for evaluating utility of submissions, meaning maybe there are different tiers of and of course there's different ways in which utility might be evaluated through benchmarks, through theoretical proofs about utility, through the different measures of utility that are, that are common in statistics and machine learning and the kinds of applications. So what's the right way to sort of like organize things? And the second, what's the right way to express that in the library itself so that a user of the library can know what sort of utility to expect from a from a mechanism that they are using, what kinds of are the range of uncertainty measures like confidence intervals, p-values, so on. How is there some unified framework for expressing these things and incorporating it into our vetting process for the library? While as Andy said, we want to have a big tent and be open for experimentation, but also have some way of indicating to users of the library what they can expect when they use things.
That's awesome. So we're at time. So thank you very much, Mike and Phil, for the discussion on the vetting process and contribution. We are ready to take a 30-minute break. And then we will come back at 1:15 and we will open up the breakout rooms again. I'm just going to open them right now. So yesterday, probably a lot of us didn't figure out how to join. So if you see, you're using a Mac, right? If you're on a Mac, I think I heard the Windows, you immediately see the join button. But on a Mac, the Zoom shows the number of people in each breakout room. And then if you hover your mouse over the number, it will turn into a join button. So that's how you can join. Look forward to chatting with you again this afternoon, later in half an hour.